Okay, so no secret, AI, it's here, it's everywhere, and it's having a massive impact on, I guess, all aspects of the data center, higher and higher densities requiring new infrastructure solutions. So yeah, just give us your take on how big an impact AI is having.
As you said, Phil, it's no surprise. Some things are a surprise. Density requirements inside the data center driven by AI is no surprise. I mean, it's really driven by this new additional network needed to tie all these GPUs together into pods and clusters so that we can do all the parallel processing, especially during that training session as we divide up these big workloads and these big training tasks across many GPUs and kind of sharing that load. That requires a new set of cabling and connectivity and a lot more density, 10x more density of connectivity required in that data center space to connect all those GPUs together.
Okay, and yourselves, Corning, you've responded to this by introducing the Corning GlassWorks AI solution, and you describe it, so maybe just the high level, but you describe it as a one-stop shop for customized data center products and services. So yeah, tell us the sort of high level view, and then we'll find out a little bit more about what are some of the component parts.
Exactly. It is a one-stop shop, starting from the conception as customers. We're working with our end user customers as they bring in their architecture of their GPU clusters, all the way from 1,000 GPUs up to 50, 100,000 GPU clusters. We're going to help them turn those logical diagrams, how they want to connect those super pods and scalable units together, and turn that into a physical infrastructure. And that service is part of our design services up front. We're really helping turning something logical into physical. So that is the key on the front end of the services piece. And then we follow that up on the installation piece with a services to help assist the installers, making sure they're well trained, understand how to use the products as the cabling is more slightly complex with a lot of unique shuffles and things like that to do the scale out of the networks as required. And then in between that, of course, are the products themselves outside of the services. And those new products are really driven by three key components. New fiber that we leverage inside the data center called contour fiber. We use that fiber then to build again, on that same density theme, more dense cables to make all those connections inside the cluster and pods. And then we're going to do that with new connectors, we call the MMC connector, on our cable assembly. So we need to really condense that space from a fiber enabling cabling enabling the connectivity to be smaller and more compact as we're trying to jam, if you will, 10x or more of connectivity in the same space, allocated space inside the data center.
Okay, and I think from what I've read, the sort of the highlight, if I call it that, you've launched the contour flow cable, which I think you referenced. Just tell us, why that is such a key component of this approach that you're taking with the GlassWorks portfolio.
Yeah, I would say, contour has been used. It's a fiber we launched several years ago, mainly in the outside plant space, where it's 200 micron in diameter, so it's smaller form factor than traditional 250 fiber. We've used that in the outside plant space to really utilize duct space as we're going, from building to building on a data center campus, kind of a data center interconnect application. Now we're bringing that fiber and placing it inside the data center for these rack to rack applications with that same kind of mentality of contour flow, which is our rollable or pliable ribbon product. That flow product allows us to build more dense cables. And again, that's critical in these spaces, both in greenfield and brownfields. So existing data centers where cable tray might be limited, or even brownfield. We're building some sites where cable tiers of trays are exceeding 10 tiers of cable trays. So when you start thinking of the cost of having to expand building heights because of cable tray, you start getting wind load and some of the seismic load requirements that make it cost prohibitive. So keeping that stack as dense as possible, when we start taking that many fibers to a rack, you have to have these dense cable designs, these ribbon-based cable designs, even in the inside plant piece of it. So that is the building block contour fiber plus the flow ribbon cable technology to really shrink our inside plant cables in the flame rated inside plant space, just like we had done in the past in the outside plant space.
Again, you also mentioned the services part, the network planning, the design, the deployment support. How important is that alongside? I mean, one assumes people that own and operate data centers have a reasonable idea of what it is they want to do and how to achieve it. But are you finding with this sort of seismic shift and just the complete change in requirements for AI that they are needing your support and education to help them get to grips with this sort of new world?
Yeah, they have these companies have some great resources, some very talented engineers and network designers, as well as they work with a variety of partners in the consulting and design space. However, the speed of which AI is moving so fast in the design to implementation stage, and the rapid rate of change, that we have to go as a new GPU is released or a new rack configuration is released, it changes up the requirements so rapidly that it's hard to keep up with the pace of those design changes. So we come alongside them and help augment and kind of be a trusted advisor in those cases to help them implement, again, that logical to physical design. So it's important to be able to kind of open their eyes to some of the new products as well, as we look at how to turn logical into physical space. You work with the toolbox, and again, the space is evolving so quickly. Our toolbox of cabling devices and assemblies is growing just as quickly. So again, just keeping the awareness in front of what options we have to implement those designs is another valuable piece of that services kind of trusted advisor role that we're taking there to work with those end user and consultants.
Okay. And in terms of I mean, you've explained already, I think, some of the sort of benefits and the reasons for this, but perhaps you can just sort of compare or what would happen if people would, or presumably some are trying to work with legacy solutions. What are the sort of problems they will encounter, and therefore why is it so important that they move to GlassWorks AI solutions and similar technologies to make sure that they're not the bottleneck in the AI solutions that all these companies are looking for?
Yeah, we mentioned a couple, but I'll just highlight them. Again, one of those is cable tray space. We've worked with several customers who, data centers don't pop up overnight. There's a construction phase. And so those, brick and mortar shell constructions started years ago, and designs and contracts are signed. We've had multiple cases where customers come in and go, hey, I've got this cable tray, I've got this ceiling height. I need to put, this many hundreds of thousands of fibers between each one of these pods. With traditional cables, I need 2x the amount of cable tray that I have available. How can you help me? And again, we go to that toolbox and say, let's leverage those new dense cables to shrink that back down into the footprint, the cable tray space that's available. We've had other customers working with, again, as we go up in the switch tier of these clusters, especially on the back end network where we're cabling those GPUs together into their own back end scale out fabric. That density of fiber has to continue to consolidate up to the spine or super spine layer in these data centers. And the density there becomes really challenging. And in particular, the connectivity. So we want to land that into a connector patch panel or a piece of hardware, and then jumper down into our switches and electronics. Again, using traditional connectors like the LC or even the MTP or MPO connector. You just can't do it. You have to take up so much space to land all that connectivity. That's where we've come in and leveraged that new MMC connector form factor to really densify that space and consolidate it so that it fits into the switch row or it fits into the overhead cable tray space hanging just below that cable tray space. So density is a key component of that. The other kind of vector that I would highlight is speed of deployment. It's a race to build AI clusters, and you can imagine the investment outlay into GPU racks. You want, as soon as that thing hits the dock, you want to get it commissioned quickly. So having these pre-terminated high-density solutions, even what we would call ganged connector solutions, where we're taking multiple MMCs, plugging them all up together into a very dense, say 144 fiber connector package, allows quicker deployments in the field. So we can do some off-site rack integration of switches and servers with those dense optical disconnects in the rack and use that ganged high density MMC connector then to make those connections quickly in the field so that we get that return on investment for the end user quicker, get those clusters up, less time spent stick building in the field, more time turning that cluster up and getting it producing compute, which is what we're making money from, right? That's what they want to do quickly.
And I'm guessing as well that I mean, cable management's always been, an issue, but is that true now? Because as you say, they often, I mean, as I understand it, by the time someone, they decide to build a data center and, design and, populate it or think they know how they populate it, and then by the time it's actually built, the requirements have already changed and keep changing. So how important is it that folks like yourselves are able to help people with that ongoing, it's not like you fit it and leave it. Maybe traditionally you might have to a certain extent been able to leave it, for a few months or years even. Now one gets the impression that things are moving much faster. So how important is it that you're there to help them, make the changes as often and as complexly, if that's even a word, as required, if you like?
Yeah. It happens frequently, way more frequently in this AI space than it did in the traditional cloud space. Whether it's, they're going to buy this GPU or this GPU configuration, and the project gets a little bit delayed, there's a real motivator to say, hey, maybe I should upgrade to the next GPU, right? Maybe I go from Hopper to Blackwell configuration because I've been delayed for 6 months. Now I have line of sight to grab that new GPU. Well, that changes the whole network design in flight. So changes like that, changes like cluster size growing. They plan on 40,000 or 60,000 GPUs, and all of a sudden the application shifts, and now I need an 80,000 GPU cluster. That changes up all the cabling, the meshing of that network design, the rail design, the fabric design in these clusters, meaning that we need all new connectivity products. So being, again, that services piece to come along beside them during those kind of inflection points, or, whether those are planned or kind of last minute pop-ups that have to be kind of adjusted for, that's what we're there to help them kind of navigate through, again, determine what their options are and what the best solution to give them flexibility in that design, but also making sure they can execute at speed in the field as well.
Okay, and in terms of the way the market is moving, I mean, everyone's talking about this 1 megawatt rack, which is, I don't know, 12 months away or maybe a bit further. I mean, I guess that changes the rules again almost, but
yeah,
how confident are you, or how busy are you making sure that you can keep pace with that? And I don't know what sort of technologies, people, I know photonic integrated circuits being looked at, there's co-packaged optics things, just whatever you can share as to the way you're looking at the future in terms of making sure that you're keeping pace.
Yeah, you mentioned the 1 megawatt rack. When we start getting lots of GPUs per rack, that creates a whole new density challenge within the rack. Now, the density challenge before was getting connectivity between racks. Now we get density challenges of even getting the fiber into the rack when you start talking hundreds of GPUs per rack. Now we're talking thousands of fibers in each server rack and tens of thousands of fibers going into a single switch rack. So that density within the rack creates a little bit of a new challenge. Of course, most of these racks are going to be liquid cooled, or all of them are going to be liquid cooled. So you've got space there that's consumed by all the plumbing and manifolds to move the cooling water around. Again, reducing the space that we have available to make all those connections. So taking that same density story and now applying it to those very kind of final mile, maybe for a fiber to the home world, the last mile within the rack, doing that in such a way in those last connections that we don't introduce adverse effects like bending loss. That's one of the values of our contour fiber. It is a bend improved fiber. So it's an A1, A2 grade fiber that allows us to put that very dense package within the rack, meet those density requirements without having adverse effects on the network link, like unplanned for bending loss, which can turn into some undesirable things like flapping of links, links that won't turn up on commissioning. So again, that creates one challenge. I think the next frontier beyond just the in-rack cabling is inside the box. You mentioned co-packaged optics. That's an exciting one that we're in the middle of right now in developing with some partners and really looking at whether that's scale out co-packaged optics or even potentially scale up, replacing some of those copper links that are used today for scale up connectivity within the node to an optical solution, and really leveraging co-packaged for some of its power benefits, cost benefits, to try to make optical as cost competitive in those copper links as possible.
Okay, so I don't know if it's fair to ask you, to finish with, but is there anything that keeps you awake at nights with this rapidly developing environment, or you comfortable and reasonably confident that the network folks are going to keep pace with all the GPU folks and whatever else is beyond GPUs, which again is a separate conversation, I guess.
Yeah, that's a whole nother topic
Yeah.
for another cast. You talk a lot about the volume, and it's not one customer doing it, it's many customers, right, that are all in this AI race, and really building out these clusters at the same time. So it is putting a constraint or a stress on the construction industry, on low voltage deployment, on server manufacturers, on cable manufacturers. So there is a heavy lift in scaling at this pace that we've never seen before in the data center space. But the market's doing pretty good. It doesn't come without its hiccups along the way, but clearly the market is doing what we can to keep up with the pace. But doesn't keep me up at night, but it keeps me very busy and keeps Corning very busy for sure. There's always that thing in the back of your mind that I always get asked is this another bubble? Does this end?
Oh,
Do
yeah.
people quit spending, right, on AI? And I would always respond to that and say, I don't have a crystal ball, but the indicators that we see in the market from our end users, from projections, from analysts, from the I'll call it short to mid-range plans of our end users in the spending that their capital outlays are budgeting for, that are very promising. For the next, I would say, 5 years. So I probably can't look out much beyond 3 to 5 years, but I see a growing need for these AI deployments that we're getting to those magical cluster sizes that have been thrown out of 1 million GPU equivalents into a cluster. And we see that, over the next 3 to 4 years that people are targeting to get to that. So I don't think it's a bubble. I think, there is still a lot to be seen about return on investment of AI in the industry and what people are leveraging that for. Do they see the money outlay actually returning profits for them? Right now I would say it's probably a little bit skewed on heavily on the investment side, and probably lacking a little bit in the return. But we definitely see projections across the industry to say that will close over the next couple of years, and seeing that return on investment really paying off from going from training to start leveraging all those models to really create revenue in inferencing.
Yeah, and maybe, and I've had a lot of your time, so I promise this is the final one. But once the sort of large language models have done their stuff and the inferencing, then there's theoretically, and there's a huge rollout of applications, and people are obviously the edge again is being talked about for quite some while. Does that present any challenges for yourselves as and when that gets rolled out and people are wanting, vast amounts of data very locally to process, send it back to a bigger data, whatever, just or is that less of a problem to solve than what we've been discussing in the main?
Man, and that is a great question, Phil, and it's one that we're debating internally of what that looks like. How centralized versus edge, and how far on the edge? Are we talking about on premise inside of a manufacturing facility? Is it at the edge in a multi-tenant data center? Is that close enough to the edge from a latency standpoint to do a lot of the inferencing? Is it centralized back at some of these larger hypers for inferencing? I think the answer is yes, all the above. And each one of those applications creates unique challenges. Clearly, we kind of know what some of those challenges are when it's centralized, because it will look a lot like the training clusters we've been building. As it gets closer to the edge, even on-prem, I think that creates some unique challenges of how to package the servers and the network to be able to do that very close to the environment that the data is being generated and being leveraged to input the data into the models and infer the output of the models. And there'll be, I think, unique challenges to be solved as we move forward into that space over the next couple of years.
Okay, I mean, it's been brilliant to chat and some great insights into what's going on, both obviously with yourselves, but the market more generally. So, Brian, really appreciate the time you've given me. Thanks so much. Thank you.
Thank you so much, Phil. Look forward to it sometime again soon.
Yep, no doubt. Thank you.